Hello, welcome to another video where I'm working through this VT500 series parser, and yeah, we'll see where it goes, I guess. Just for an example, we have to redirect standard F now, but um, it's got some things. I've got home row modes, and I would have accidentally just pushed a key. But so say I have that, and I kind of resize it. It kind of resized it naturally. If I kind of go back, it just naturally goes between the two, so it can do full resize. It's got a nice little border. What I might do is start on the next kind of portion. In fact, that's kind of interesting that the cursor stays at that point, though. No, it does reckon that the cursor is there. That's kind of interesting. I'd have found a bug. It's what happens when you do that. So if I do like a comma there and then do that, cool. Now if I go like that, yeah. I think the cursor should change when we do a resize. And like, how do we want to kind of go about working out where the cursor is? Because we could either do what it's like currently doing, and it's remembering the last place it was. So here it's at 2.6 by the looks. And so if we go out, it's still at 2.6. Could be kind of good to get in the keywords. So like if I push an arrow, it'll arrow out because we got escape. So perhaps what I might do is look at doing some escape sequences. But yeah, have a ponder on how to think about like the cursor on resize, because the other option is you could work out kind of where the cell is where you're currently at, and then try and stay on that cell, which I think that is probably correct. So um, so I guess size T, this is going to be like a cursor, a rig cursor, and I want this to be the current cursor dot y times the window dot ws col plus the cursor dot x. Now is that what I want? So like when cursors get used, so when cursors get used, we might have a wrap pending. I think wrap pending should probably get ignored. If we're not at the end of the row. Yeah, I think that's probably what we want to do. So yeah, we'll fix up some things. So the original cursor is at that position, but what we want to do is, do we have just the original size? Yeah, so this we actually want to be original size dot w. Oh, and then the new so we kind of want to make we kind of want to do this. So the X component of this is like the mod of the new size. So I think I want to do here cursor and the mod of VT window .ws. Oh, yeah, and the Y is just going to be the division of that and into the division, and we'll just kind of work out. Now, I think that might be what we want, and who knows, we can do some little tests. So if we're here and we go to here, this didn't put it in the right place, and that can't put it back. All right, so that didn't really do what I hoped it would do just out of the box. And we also need to check whether VT cursor dot x equals VT window dot ws. Oh, I see what the issue is here. This will never be the case. In that case, wrap pending, it can equal that Boolean case, but it won't work. The problem is that we are offset by 1. So this will be like, yeah, I think what we need to do is do that and that. So that will be that. And then this mod kind of makes sense. Kind of. We kind of just need to add 1 to both of them. So if you mod by this, you're basically ignoring this first thing. So it would just have this left over, and because you subtracted 1, you want to add 1, and that happens after this operation. And if you want the y, you divide by it. So this would cancel out, and this would also kind of cancel out because it's less than, and so you'll be left with this, but because you subtracted 1, it should be that. And so like maybe that is what I want. So if we get to, I don't know, the end there, and we're wrap pending, if we kind of go round, we kind of put the cursor back and forth. That looks quite good. Now, if we are here again, we're wrap pending. So here, if it was wrap pending, I want to add 1 to it. If it's not at the end again, because otherwise we'll just overwrite that. I think that's kind of what. So if VT cursor wrap pending. So If it is if that is not the case, then we want to cursor.x plus plus and VT cursor wrap pending equals, well, I think I don't want that. And then here we'll just set it to be whatever it is. Because that way, if you were one before, when you do the plus plus, it should go to it. Yeah. So if we get to a point here, I should make this window a bit smaller. So we're wrap pending. We became unwrap pending when we had the space to. And then when we came back here, we, I guess, forced that wrap to happen. But do we want to force that wrap to happen? I think that's a difficult edge case to catch, actually. So what I can do is if I get to kind of one before, go to that mode, go one more, then do it. No, we don't have. It doesn't exist. Cool. So if that is the case, yeah, I think that one's a bit too tricky to catch. Like, you could see whether the thing's used, but like you can't really tell whether you came from something before. I think once you resize and you've made the determination, you could go to the next character. You should just stick there, and if you come back, it's just lost information. Which I don't know. It is what it is. Anyhow, there was a thing that I wanted to do, which this is like all kind of fun and games, but it'd be cool if there's a few things that would be cool. It'd be cool if when I push a key, it kind of registers the fact that I pushed a key. That kind of makes sense. So you can kind of see which keys are doing. This current parser would need to get changed a little because currently it's difficult to detect when escape key is pushed, like the physical key. Because every single escape is treated as a brand new escape in this state machine. We look at this. Every single escape, so 1B is escape character, every single one goes back to this escape as if it was never called. So what I think I might do is maybe implement some escape sequences, and in particular, I don't know, I've done one. It's reasonably easy to kind of trigger one off. So at this point here, we are wanting to do the clear. So it's now kind of saying that we don't have that. So it's kind of interesting, this VT clear, because the way escape works is you get these things called collect and haram, and I think there's another collect here, and there's like param here, but there's not a collect. There is a collect there as well, but slightly different cases on each of them. But if we look at what clear, it causes the current private flag, intermediate characters, final character, and parameters to be forgotten. So there's a few things that we need to remember. And I guess that kind of means that at the moment we don't really need to do anything, but perhaps in a bit we do need to do something. So what we could do is I kind of want to say what the size of BT, what the size of the BT object is. So if we do just escape, that's what we want to do, and we should get. Did we not get that unemployed? I pushed into not escape. Other hand. Right, so here we get the size is 8. So what I could do is I might do a similar setup, VT clear, and we can just pass in the VT, and it shouldn't really require anything. And then up here we can kind of, I don't know, get that and then get that and clear. It shouldn't need anything, and we lost that. But what we could do is do a static assert, and we are going to do a static assert that size of BT equals 8. And when it does not, more states state added may need clearing, and that just kind of prompts me to when I add stuff to the state. So if I let's get here, if I say, well, maybe we need dirty A, and if we run this, it should complete. Maybe if we do indeed B, I see what's happened. Yeah, so that size of VT, I kind of, so because I've called it BT, it's kind of looking at that. If I wanted to look at the type, which is also called the same name, and depending on the context, this will be different. And so this will, an 8 is a size. It's a particular size that you would know. It's like the state size equals percent LU, and then we can go size of percent BT, not percent. See my screen, you kind of know what it is. And we kind of need to take out that and do an escape. And so here we can see it is 128, and did we add that dirty A? But we can find that dirty and add it in. And here we should get it complained. It did not. Yeah, so because it's a bool and a bool next to each other, it's just like I can just squeeze that together. So compiler did that thing, but here state has been added. I guess that does kind of mean that you can't really detect if another ball was added just straight after each other. But my idea is because like you might have something like this. Like I want that to tell me that I need to do a thing, but it is what it is. But that means that clear we can kind of say is done. And so now I believe if I do escape, state is now escape, and I could do a different key. So what I might do is if I can push this key, and that was an arrow key. So I just push the up arrow, which I am going to use to kind of navigate the screen if it is input. And we'll get to it. I've got another idea of. I mean, I've kind of got this in a thing. So if we look at here, and like if I run like use a build bash, I believe, we can't do that. We can do that, but it doesn't kind of work the way I want. Here we're running cat inside of it, and the arrows will get sent through as is because it's got a program underneath, and instead the program underneath will do whatever it needs to be interactive, and then whatever that program prints, this application will receive, and then it can update its version of the screen internally, which I thought could be a kind of cool thing to do. You might see that I've got another thing there, which is more of a rush job, I guess. But yeah, so what do we need to do? We need this CSI dispatch. I mean, we're already up to CSI dispatch. That's kind of cool. I thought that I would need a bit more. So I guess what we can do is VT CSI dispatch. And I kind of want to do a similar thing here where we can just kind of do that. And I'm leaning very much to doing something so I can just have all the execute things like this. You see, I've just got one list and I define it like that. And then I don't have to kind of do every single one because I have a feeling that it's all going to be quite similar, but it's all going to be one line. And I wonder if I go ahead and do that now before I kind of run off and do things. And all it would need is kind of adding this S to the action, which that S is reasonably far over. It can probably be one back. Now, I wonder. So this is. I'm going to try some Vim stuff because a good time to try Vim stuff. A bit like a thing sticking out of my chair. Cool, got it. So if I have a look here, I want to get this. So and that doesn't really happen again in the format that I am expecting. Cool. So at this point here, I want to start a macro. I want to save where I am. Maybe save it there. I want to yank the thing I want, then I want to search for the thing I yanked. That's not the all right. Start a macro, record where I am. I'll get just that, and then I'll search for case space the thing that I'm looking for. See that? God, extra stuff. Because what I want to do is basically, well, I suppose I can just do this. Recording macro, save where I am. I'm gonna search for just the thing I wanted. But now I'm gonna do like Q. See, I can't do that. Right, so from here, I want to be here. From here, see where I am. Can we do this? Then that. Then that. Then do something like that. That kind of works. And then we can probably just get to the end of the line and then go back to where we were, find that, then do yes, paste what we just saw. Then do something like that. And then down one, and then 0, then find that, and then across one there. I think that's kind of what we need to do. And to test this, I kind of want to come down here and just see what happens. So if we do that, so we can get rid of the return. But now this is looking good, so I might just do that. And what if we just do that just for right, so all these returns, we can probably just replace that with nothing. Yeah, and then that looks kind of nice. And we can probably do that sort of thing and like easy align. And now we get into like regex mode. Help easy line. Yeah, that one too. Control X. Control X. Cool. And I want to do it on that sort of thing. I didn't really want to get that one there. And it's not quite what I wanted. But yeah, then I can do that. And you might wonder, what on earth is the point of all the so if we down a bit and a bit more, a bit more. This function here is basically now what the VT action does. So we just do this and can probably just replace execute Jones and replace that with John. Do something like that. And there is only like 14 actions, I think. And this is just going to be input. And this is, that's good, unexpected input. And what are we currently doing? We currently do that. And then we can kind of just get rid of this code and we're just kind of left with that, which is quite nice. I like it. Doesn't like it. That's because we're like defining stuff that doesn't exist. That's cool. I think I might just go back to the one. We can go here and so if we go here, and just one more. Do something like that. Cool. So now this that was like going to be CSI dispatch, and we're going to take in the BT CSI. So we don't have that yet, but we can get there. So it also reckons that we haven't got this. So how do we get that? Right. So what we want to do is in this we're going to use a whole bunch of different things. So what I might do is we're kind of going to do this, but they're going to be like that. And to start with, we can define a couple. So how do we get that? I think these names were the best, and like 107, I don't know. We'll see what that is. Oh, that's pretty good. 107 is actually quite good. So control ones. Then we have control functions. That's all good. Escape things, control sequences, parameters. So CSI things. That's not saying things. That's all good. Um, Right, so we just have to kind of search up and down. So what I might do is we'll do up, down, left, right. Look at that. A, B, C, D. That is kind of the code set it is. And this is a CSI. So if we search for that didn't really Oh, does this do like reg? Can we do regex with that? No, we can't. Um, arrow. Um, this thing was potentially all right. So we can have it doesn't do things that aren't. Oh no, it does. Yeah, so CUU. Oh, this had it. CUU. Yeah, CUU. And if we search here for CUU, oh yeah, by final character, this is kind of what I want. So CUU, CUD, CUF, and guess we get the CUD. So what we can do is do that, and so I guess ASCII. I do that. I want to see that's 41. I should remember that. Past life with me did. So this can be CU. And here we can go back to CSI, CU, which we are going to do that. Cool. And I mean, we could put these as like that, which might be easier for people browsing the source. I potentially might go through later with just a script that will go through and put a comment next to these if it is printable, what the printable character is, or if it's not printable, what the like code that you might call it is, like these codes here. But for now, that's that. So it was down, forward, and back. So if we find that and that, down, forward, back. And then from this, yeah, then we can get this sort of function. I mean, I kind of want it for both this and that. That makes sense. And then we just define C to be blank again. Cool. So in this case, we can now change this. Did we have it? No. Oh, did we have it for this? Yeah, we kind of did. All right, so execute function, and we want to kind of just VSI and do that, and then kind of want to do this and that. Thanks. It's kind of nice. And then here we can CSI function input, execute. This is like kind of control function, and I wonder if I want to do a global replace for execute that and change it for control. That. Yeah, because of this, we can pull that out as well soon. We also need to do that same thing, but for lowercase things. What's that broken? We don't know that type. Where do we define this type? We define it there. Cool. So I kind of want control for that, and also for that. And I hope you see the power of these X macros. Cool, and now that's just undefined. But if we look at when we do this, I mean, it's just what he called it. So if we ignore that and kind of come down to CSI dispatch, even that, because this thing here, if we put it up, yeah, and do that sort of thing. Can we just do that? Um, and the CSI function, did we like define stuff with that, or yeah? So we also did the function list. So what we can do is the CSI dispatch. We can kind of bring it up to where like one of these are. I don't know, probably above action. And so here we are CSI, and we can change this thing to CSI function string, which I guess we need to define like this. And we should have that, should have that. So I guess we need this, and we should have that, we should do that. Cool. And so right. I feel like that should. I don't know. I need to look at the uh, GCC minus E. This one. If we look for this thing, doing that, and then it's doing return. Yeah, so do I want it to like add a new line? Is that kind of what it wants? Um, 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 like this worked before, right? Case name code return. And it's like only this one, is it? And then that's just that. This needs to be, we have that, and then can we do that? Yeah. And also, yes, do that one. One, I think. Part is cool. Now it's down just to an implicit declarations. Cool. So that means like all of this stuff needs to be above all these kind of handy things. So I guess, and this was the case that was all good there, and I can use that legit. That seems legit, but I think it doesn't look that nice. Cool. So maybe if we search for that and then underneath these, I guess. Cool. And then that just works perfectly. So now we should be able to get maybe a bit more. So if we go up, what did we get? We process that. We don't have action ignore. Ignore. So action ignore, I think we just want to, can we do that? I don't know if we can. We can do something like that. is just a not type thing. So that means now we should be able to maybe see a bit more. So what did we get? We transition to escape. We did the clear action. We are now in that. We now get a CSI entry. Cool. We have an action clear. Perfect. We know how to do that. And now we're in dispatch and unknown action 7. 254. G. Unexpected action. And like, why doesn't this complain? We are now using it. So action is when we have state this, action is clear. So in the actions list, did we not have clear? We did have clear. Does that mean we're not? We do return from there. I kind of want to see what the output is. And what were we looking for? So unexpected action, that is on 254, perfect. So if we scroll up, we should have some stuff in like when we had clear. Nor we do that. Got like a double thing. I don't know if that matters. Clear, we run that, we return. Okay. Action is CSI dispatch, right? So CSI dispatch, and that we should be hitting with this. Now, is this an issue because we and my input's 41, and then unexpected action is 17. We're meant to be switching on the action. Cool. Look at that. And now it knows that we did the CSI CUU. That's pretty good. Cool. So if we can get that, that's quite cool. So now I guess in the VSI function list, how would we implement these things? And like we could potentially call out to functions that do it, but so like CUP where does it actually like define you? Cool. This is exactly what we want. So CU moves that many number up in the same column, stops at the top margin. If we're already there, we don't go anymore. I think that's pretty good. But it doesn't mean that we kind of have the notion of some arguments that have been taken up, which in our case we don't have. But I mean, we can maybe simulate that if I go printf dash e dash dash no, just that, and then I don't know, like 2, then a, and if we just printf that to there, yeah, now we don't know action param, and I think that's potentially slightly nicer to do first, because then we can kind of work out what's what. So action param, and that is kind of in here. It's like a little confusing kind of going back up here and seeing that this is kind of where things get defined. But yeah, we can kind of collect parameters. And I think I might do something like that. Cool, and then that's that. And then when we do this, we can have something like that, and what was it? Param, and we are going to take a value int 8 the input, and when we do that param, did we pass in the input? No, but we can pass in the input there. And so what does this bad boy do? So this is kind of, I guess I'll just print out input seat O to X, and then we can just kind of see what we and perhaps I'll even let's see. I think there's like a way to kind of say read this one, but oh well. If not VT, return, return. Cool. So now it should hopefully compile and run. Right, we're passing in stuff, but here you can see here that we're in state param. We're in state param. So this is the function that we're looking for, which potentially we could grep for that in particular. But you can see here that it got, perhaps I will do grep for in, we can probably just search for that. So in VT param, if we research that, restart that, we should get 2, 3, 4, semicolon 1, 5. And so you'll note here that we, in this text, get like everything, but we want to be able to store a certain number of parameters, and we want to be able to know whether it's a default parameter, I believe, or whether it has been set, because it potentially might just get set to 0, but that doesn't mean it needs to be the default, which potentially is also 0, or it could be 1, or it could be 10. I've seen. So how on earth does one kind of store that sort of information. I believe it only needed 16 parameters. So collect, it can have as many as thing, but yeah, maximum 16 parameters need to be stored. If more than 16 arrive, all the extras can just silently be ignored. So what we could do is type def struct, and this is going to be a VT arg, or program maybe. And so here we're going to have whether it is default. How do I want to say this? Specified, non-default. I like to be zero initializable. So this whole structure gets put onto minus a couple of pointers like the file IO and the cells. It gets just put on the stack right back in main or main loop. And because of that, everything is set to 0. And so it would be useful if 0 was a useful, if 0 meant like not in use type thing, like if 0 was a good initial input. And I think non-default is how it's going to be. Otherwise, we're just going to have int. And I believe so it also kind of means that if like you can have quite a large value, but you can't have a negative value. So I think that's critical. So we could have like a uint 16t, which would be able to cover that. Goes up to 65,000. And that's potentially fine. Like I'll just kind of leave it at that. And oh, that got deprecated in the. Oh no, that's good. 0 default mode. Right, so kind of 0 is the default, but I think we'll just treat it internally, and if things break, let break. So we can have a uint 16t value. So that is going to be our value that we're kind of storing. And I think I'm a little conscious. No, I did not. I thought I left a training space somewhere, but just in those 2 locations. Which that kind of works. So when we get a parameter, we kind of need to see if is digit. If it is a digit, then we want to see which one we're up to. So these VT params, we need to have params and 16. I'll just say there can be 16 of them. And size the num params. And so it'll start off with 0. And so it'll just kind of work there. If it is, we have a number, we want to check whether the number before is kind of relevant, I guess. So If num params so yeah, we um and this is non-default. So if that's the case, so if we have some params, so we can subtract one off it, and if the one before us is non-default, then we want to set things up. That's because we have something weird in my search. Cool. So if this is the case, the thing before us has a non-default value, then I think we just want to append this digit to that digit. So we would take the VT params and VT num params minus 1. And this is going to be our uh, dot value. I think we can do dot there because we've done the square bracket. So we're first going to do that. And because of that, I kind of want to do VT or RAM, and then find the dot, and then RAM value. That seems good. From dot RAM. And that is going to be plus equal to input minus that sort of thing. So if that is not the case, that just means that we are either on the first one or the thing before us was the default. Um, 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 yeah, because it's that, so that means that it was the default. Thing before us was the default. It's now no longer the default. So we should non-default equals false. So it is now the default. No, that's not right. It's kind of annoying the non-part because it kind of takes like a double negative meaning when you kind of try and reason with it. So the other cases, like the thing before the parameter that I'm currently processing before me is not the default. If that is the case, that means we've got a current value going. Perfect. Otherwise, that means that either we're on the first value or the thing before us was the default. And I think in that case, we just want to look at where we are. Not like that. Find that and again and again. So I think I wanted to do something like that, which will move forward the number of parameters because we're now making a parameter, but we'll take it from wherever we currently are. And so at this point here, we want to say that it is. No, I want. So, like in the first case, we'll have a digit, and we'll probably be in this case here. So we want to say that we have a parameter. So we bump that up by 1. And it's not the default because we've got a digit. And we can set that digit. And then the next time, if we get another digit, we should be in this case. Because we have one, the one before us is non-default because we set it that way. Otherwise, in this case where we don't have a digit, we kind of want to say the thing that we're currently looking at is default, so is not default. So it is default. Yeah, I think that kind of makes sense. And we could potentially do that. And just because we are setting it in all 3 of these branches, at the end here, we should have it pointed to the param. And param so far is D or default equals %D as well. We can do that. And so here we can have param value, and we can have param non-default, but we not it, which I think will do what I kind of wanted to do. So now if I do this and run that, we should get we're getting some issues. So this is an interesting one. I was talking about it just before. We have added some state to our VT object. So what we add? We added quite a bit actually. So what I might do is that's kind of weird that it went there. It was like a filthy tag. No more. Or what even was that? I do not understand why. It's kind of weird. It's anyhow. That's just the problems. So what I might do is unpull size of VT equals and du, and we can do size of VT and do something like that. And then if we error that, we should be able to get the size is 200, and so we undo that, that, and then find one, and when we get up to 200, so we can say it's now 200. And so here we get all the way through. State param, we can do that grep again, actually. So if we do that, param so far is, and we can have a look at what we're doing. We're sending 234. That's 223, 224, and then param so far is that. Default is 1 for the second parameter to start with, and then we get 1.5, and the default gets sent back. So when we do the CSI, I think I want to just kind of get rid of things there. So when we do the CSI, params, and we can pass it the size of it. And then do something like that. We can probably do EU params, do something like that. And then here we can go BT num params, and then here we can go for size T I equals 0, I is less than T num params plus plus. And so in this, we can kind of do that, and we just want to do U because it's unsigned, and we can just have that. And I think I want to go VT params I value, but if VT params I dot non-default, you will do that. Otherwise, we'll do this, and then here we can go default. And here we can just have something like that, space separated. And then here we can close off that whole debug thing. So now if we do this, we should get a different function. What we can do is go back to this, and then we get 3 parameters, 234 default and 15. So we skipped that 15. Nice to know. I think this just always wants to get the thing before us. Yeah, now we don't get the second one. Something like that. Is that what I want? Yeah, and then we get 2, 3, 4, 15. And we can experiment by chucking in a default, so that should be a default in the middle, and then we get the 2, 3, 4 default 15. And that's looking quite good. So all that really means is we now have stuff to clear, because we never actually did anything in here. So I think we can probably just go VT. Well, first off, if not VT, we should probably return. And here we want to go something like VT num params equal 0. Perhaps beforehand we want to mem set. So this is source, the buffer, the character, and the size. So the buffer is going to be BT params. The character, we're just going to print a little null character, and I want this to be size of the size of one param times the size of well, this can actually just be BT slash num params. Now, num params can't go over 16. So if we are in this case silently ignored if BT num params equals 15, well, size of VT params. That VT params, I believe that is what I want. So if in this case, if that is the case, do that. And then here we should probably, if param, do that. And here we can set this to be no. And then if param, we can print this. Otherwise, programs ECU, and should probably do that and ignore more. And so here we want to do BT num params, and to here, and I think we want to do that there. So if we do this, right, so we can put it in a mode. So if we just do that sort of thing. We can go escape. We can go open bracket. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17. Yeah, so why we get up to there? Something like that. So get into that mode. 1, 2. Okay, escape there. So if we just bugger, I didn't put it into number mode. So if we go here, we should be able to set something. We should be able to set something. Would we process that? The 3B. All right, so it reckons I did kind of put in that. What if I do that? It went up one. So this also needs to be that same condition. So we should get 14. That we want to get into that move first. On-prem's 15. I feel like we need to do like one that we keep. So we'll get 1 to start with, and then on there we'll get 2. That could be legit. And then here, if we do A, because it does know A. So here, 15 values, 1. And so the last one is that. So I feel like we should be able to squeeze 1 more. That seems not right because no, I think that does kind of seem right. So we should be able to get 16, shouldn't be able to get more. So I have a key that I need to push, get a number. So number, and then ignoring more, and then I have to push the right key so that it actually shows up. And so here we get 16 parameters, and I'll assume that there's 16 of them. And then we do whatever action it is. Cool. So when we clear, we should do that. So if we do escape again, like we should just be in new mode and we have num params reset again. And if we do that, we should, yeah, no, that looks all good. Cool. So in this dispatch, what do we want to do with this? Like, do we want to define it here? I feel like yeah, I think we can do something like that. Cursor dot y equals, and now it's going to equal a thing, depending on where the cursor dot y is. If it's greater than equal to VT params value, and this is going to be VT params dot non-default. If it's the non-default, then it gets that. Otherwise, it gets 1 in this case. And I feel like a macro to get that out will be good. So maybe we can be fine. The RAM IDs and default. If it does have a default, and if it doesn't exist, what do we want to do? Perhaps just throw an unreachable in this. IDX is less than VT num params. Then we do this. Otherwise, we just get the default. We can just specify that. I think this whole thing warrants that. Now, if we have that, so I think I want to gang to that. If non-default is the case, then we want to get that dot value. Otherwise, we want to get the default. So this can be so it'll get the default if it's over, like if it's past the end, I guess, which I don't know. If you try and get something that's past the end, that's kind of what you get. So now we can go VT param and pass in that. And if that is the case, then we VT cursor dot y minus VT param VT there 1. Otherwise, it'll just get set to line 1. Is that what I want? The current cursor is, I think if it's greater than, something like that. Um, that's what I wanted. But that one. Something like that. And so I guess this default, we should probably recommend that just in case. So now if we get to the second line, we should be able to push the up arrow and should have moved things. So we got 0 params, which should mean that we get the default. Yeah, would have thought that. So what we could do is if std error t ran VT there 1 equals, and we can just not see what it is. VT ran VT of 0 1. And what is that? That. So now if we get to here and do another thing, so pushed up, it reckons it is 1. So at this point here, cursor must surely be 2. Cursor dot y. Cool. We'll see what this gets up to. Doesn't like that. But if we do something like that, so if we do something like that, next line we can go up by 1. And so here it was 1 and y equals 2. We do it again. Y was 1, but it didn't redraw. So I guess this should do a redraw. VT 30 equals true. So something like that. And now if we shouldn't print the others, but now if we go up, it goes up and we can go right there. We can go down, but what we can do is kind of do that. Can probably do something like that, and then here when we're going forward and back, I want to replace dot y with dot x, and same thing there. And here when we're minus equaling. So if that plus that is less than VT window.ws. What are we doing? Y, so row. Then we do a plus equal there. Otherwise, it will just equal to VT window.ws row -1, I guess. And so here, if we find the S, I guess, and yank in there, we can probably do that sort of thing, and then that sort of thing. And then, yeah, we also want to change those Y's to X's. And the row with, just there. And I think that's potentially enough. That doesn't work. Right. So here we just need that, which does that. Cool. So now we should be able to. Okay, we can't go right, but we can go the opposite way. So what I need to do is, guess do something like that. And maybe go back to here and then do that and that. So we can go, make sure we go, yeah, we can go down, we can go up, we can go that way, we can go that way. And it just updates where the cursor is. So that's kind of cool. I think that's potentially enough for now. Yeah, I mean, it kind of shows how you can build this out slowly, slowly, slowly. And here I'm still unsure whether I want to have the X's here, but I think it's potentially better because then you can kind of just do like that sort of thing. Well, it's more like this sort of thing, like that and that, and make an old param, but actionless. Yeah, potentially this. Uh, should go up above here, which looks kind of good right next to clear. And that's that, and we can kind of go in and reload there. We can go and do things. I didn't like something there. And if we try and go down at the, yeah, so we haven't quite got the limits. I can't quite go all the way to the edge. So in wherever it was, that just means that that's not it. If this is less than, just shove an equals there, I think, and so now if we try and go all the way to here, it kind of pushes you back one. Do we just want to get rid of that? So if we go all the way across, we should be able to go all the way across. Now, if we go all the way down, we should be able to go all the way down. And we seem to be bounded by that. And when it starts, it starts. Cool. So that's like one function, but you can see it. I don't know, it depends how you do it. I'm unsure whether I want it to be up here or not. Perhaps I do, perhaps I don't, but like some of these, you can kind of, yeah, I don't know, but I think I'll leave it at that. It looks kind of cool coming along, and we can arrow around. I mean, it's just kind of the start of this inner input, but in theory, like we could start doing something like escape square bracket and then like 41M, and here it doesn't know what M means, but unexpected CSI function input 6D. We could look up what M means, and then we can see that it's SGR mode, and then start doing SGR stuff. And yeah, it's kind of just pads out slowly. But the idea of these state machines is you kind of just have massive lists of like enums, really. Like this is just a big lot of enums. You do a bunch of enums here, and like maybe every time you hit a switch, it does a thing, and then when you hit a switch, it does a thing. And so this S we don't actually have up here. We could. It's quite gnarly though. So like if I look at it, this is kind of what it looks like at the moment. But like for all of these, and like these are quite long. Might be able to find a way to tidy it up. If there is, then boy, I will definitely shove some S's up there because it might save a bunch of time. But yeah, I think that's that. So what I might do is we need to do a reset because something went wrong. We aborted. So if we look at that and that, sure. And we can kind of see what we did. So if we did that, we took out a bunch of stuff, but we added in like double the amount. So we're adding more features, but we are also deleting stuff as we go by kind of moving into the X macro type stuff. But yeah, we'll commit up that. So what's this done? Add support for CSI programs, action for errors. Something like that. And we can just push that up and call that done. But yeah, thanks for watching. Hope you enjoyed it. If you didn't, just watch another video. If you did, like, please check out my other stuff. I do a whole heap of different things, and sometimes you might be able to see why I do certain projects in certain order and maybe where this particular project might be going, but who knows. Thanks anyway for watching, and I'll see you next time.